from the heart of rural France. This is the Keto Woman podcast, brought to you by me. Hello Keto lovelies, I'm Daisy Brackenhall, and I've spent most of my life struggling with my weight and confidence, and have always had a difficult relationship with food. Even when I finally got to my target weight, after weight loss surgery and eating low carb, I couldn't maintain it and I was miserable. I've been keto now for over 2 years, and it has given me the freedom to fall in love with food again, without the constant gain, loss, guilt, virtue cycle of before. Health and happiness is where it's at now, running on fat. Welcome to the Keto Woman podcast. Each week I'll be chatting to inspirational women, maybe even the odd man, to discover the secrets to their success so that I can share them with you. So what is keto? Keto is a way of eating that enables you to switch your body's main fuel source from sugar to fat. Who doesn't want to be a fat burner, right? But how do we achieve this? A great place to start is by keeping carbs under 20 grams a day. So things like leafy greens and above ground vegetables, plus some nuts and seeds and the incidental carbs you find in things like full fat dairy. Choose delicious fatty proteins and be free and easy with oily dressings on salad and butter on your veggies. Once you're in the swing of things, you can tweak it to suit you. Make your own personalised keto. You'll hear all sorts of ways to keto from my guests. There is no one way to do keto, no one size fits all. I hope to show you just how flexible and fabulous this way of eating can be. I'm not a doctor, and most of my guests won't be either, so we really can't give you medical advice. It's always best to consult your own doctor when making big changes to your diet and lifestyle, because they know you and your medical history, and so have access to the bigger picture. Wouldn't it be helpful to have one place where you could find all the links? Want to sign up to my new Patreon exclusive Facebook group, Daisy's Lovelies? No problem. How about subscribing to my YouTube channel? Please help me notch up my first 1,000 subscribers by going to links.ketowomanpodcast.com and following the YouTube link. Not following me on Instagram yet? Hit the Instagram button. You get the idea. All the buttons, all the links you need are at links.ketowomanpodcast.com. Thank you, Catherine Howlett, for supporting me in this podcast by making a pledge at my Patreon page. Do you want to hear your name here at the top of the show? Are you enjoying this podcast and would like to help me make more episodes? Then head over to my Patreon page at patreon.com/KetoWoman or hit the support button on the Keto Woman podcast website. It means a great deal to me, and you will get to headline the show just like Catherine did today. This week's extraordinary woman is Elena Gross. Elena has a background in neuroscience, University of Oxford, and is currently finishing a PhD in clinical research at the University of Basel, Switzerland. She is also a migraine patient and a keto enthusiast. Frustrated by the available treatment options for migraines, her research career has focused on better understanding this common and debilitating disease with the ultimate goal of improving clinical care. Elena is particularly interested in the role of energy metabolism in migraine parophysiology, as well as other neurological diseases. Her and her lab are currently conducting a randomized controlled clinical trial on the efficacy and safety of exogenous ketone bodies in migraine prevention, the first controlled trial on ketone body salts. This recording has been a long time coming, and I first approached Elena many months ago. It was such a pleasure to get to chat with her, and I found it fascinating to find out more about migraines and the research she is doing. It is also not every day that you have a long-standing health mystery solved. Bonus. Welcome, Elena, to the Keto Woman podcast. How are you doing today?
Hello, Daisy. Thanks for having me. I'm actually very excited to finally talk to somebody about migraines who knows what migraines are herself, which is really cool.
Oh, yes, absolutely.
There's nothing better than introspective when you talk about a disease, if you actually know what it is like, right?
For sure. We've been trying to record this for ages. Funnily enough, we were laughing about this before. We've both had to cancel due to migraines at some point, which is kind of funny. But we're finally here, and it's fantastic to be speaking to you.
Yeah, it's certainly also been my fault for having to finish the PhD thesis and lots of things going on. So my defense is in 2 weeks. So I'm still a little bit stressed, but fairly migraine free. So it's all good. And I've been looking forward to this since you asked me like months ago.
Yes, it was quite a long time ago when we started talking about it, but the timing worked out quite well in a way because, yes, like you say, it's good to finish your thesis first.
Yeah, and you even skim read it. I'm well proud of you.
I did.
And honored. 250 pages. Well done.
Well, I was very interested, and there were all sorts of things in there that we've chatted about a little bit before we start. So we'll have to remember to bring up all the points in our actual recording.
Okay, great. I guess you have a list. Otherwise, I'll pull out the thesis again and we can go through it.
So let's start by hearing about you and how you got into keto, how you got into your migraine research.
Yeah, so as you can imagine, or as I already mentioned, I'm a migraine patient myself. I think it started about when I was about 14, maybe. Half a year after I started the contraceptive pill, which is very interesting because having talked to a lot of patients within the course of my study now, there seems to be a connection to starting the contraceptive pill and migraine onset or migraine worsening. But I just went to several doctors. Nobody knew what was going on, psychologists and whatever, brain scans. And finally, I diagnosed myself using the internet, actually, with migraine. And from then on, it's basically continuously gotten worse. So despite trying everything, and, when you're 16, you're trying to go out with your friends or have a drink here and there, and the least you want is really have a stable lifestyle of going to bed at the same time and not eating all these triggering foods. But I really tried. And despite all efforts, alternative and medicine or pharmacological therapies, it just got worse. So after during my bachelor's degree, I was always interested in the brain, but I started reading psychology in my bachelor's degree, and my migraines actually became chronic. And that's something where you have more than 15 days per month of migraines, or at least 8 of those have to be migraines. The rest can be headache. And it's really crippling. Your migraines are starting to control your life. You cannot go anywhere with that pain. I mean, you know that when you have a bad migraine, you can't really control or ignore pain in the brain, really. It was quite tough, and you never knew whether you could take exams or whether you would have a migraine that day. And for social life, it was really bad. People don't understand. And by the end of the degree, I realized that I couldn't be doing a normal job with these migraines anyway. So I decided I'm going to change my career path, not become a psychotherapist, but go and read neuroscience instead. And maybe within my lifespan, figure out more about what is a migraine and what can we do to actually treat it. So more looking into what might be the root causes. Where is it coming from and why? Because I went to so many specialists and nobody could actually answer that question. What is a migraine? Why are we getting it? And of course, you can't treat it.
Yeah, because if you want to really properly treat something, you've got to find that root cause.
Exactly. Not just treat the symptoms, not just treat the pain. And as we discussed earlier before this recording, with triptans, those acute migraine medication, or even with analgesics, you cannot take them more than like 10 to maximum 15, but that's already pushing it, days per month, without getting medication overuse headache, or at least risking to get one of those, because your brain basically adapts, and then it adapts to having these chemicals around. And if you don't have them around, then you get something like a rebound headache. So your body is anticipating what these triptans do to your serotonin receptors, because they're serotonin agonists. And if you don't have those around, there's not enough serotonin anymore to basically endogenously activate those receptors. So then you get a migraine when you don't take those drugs, which is even worse, right? So it was like a vicious circle. So I was stuck in that situation where half the time I could not take anything against the pain. And that basically means you're out for days in your dark room and you can't do anything. So very unsatisfying. And this is why I then went into neuroscience, and I was lucky enough to have an open neurologist in Oxford who took me on, and I did both master's projects or thesis in migraine research. With chronic migraine patients was one in neuroimaging, and the other one was stem cell, iPSCs induced pluripotent stem cell research with migraine neurons, basically, which was also interesting. But for me, it was most fascinating to be close to the patients in that neuroimaging. And there was this one incident, and I still remember very clearly, where the scanner broke down for one patient and she had to come back. And she comes back into the lab the second time and I almost didn't recognize her. She was walking up straight, she was smiling, she's lost weight, she was like a completely different person. Back then I already started forming my theory that migraines are at least in part an energy deficit syndrome of the brain. She comes back and I ask her, what did you do? And she told me she'd been fasting for 2 weeks. And that completely shocked me because I was like, oh my God, she's not eating for 2 weeks. And we know that not eating is one of the most potent migraine triggers, right?
Yeah, typical trigger, isn't it?
Exactly.
Yeah.
And she was having a glass of red wine every night and it was fine. She had not had a single...
That's magic.
It's like, what?
She's
This
a witch.
is like, I couldn't believe it because this is Oxford Medical School or Psychology Medical School, both together at the neuroscience in Oxford. We did not learn that the brain can metabolize anything else than glucose, right? So I didn't even come across ketone bodies during the whole year of my studies there. And so I was shocked and I didn't understand it. And I went about and towards the end of the degree, I was procrastinating in the library again as usual and was flicking through a Nature magazine and it had an epilepsy special in there. And one of the articles was actually on the oldest treatment for epilepsy, the ketogenic diet. And I read upon the mechanisms and this was like I think this was the best aha moment I've ever had in my life. I was like, okay, this explains this incident with the patient. And this could also be the solution because reading upon the mechanisms, they were all migraine relevant. And few people know that actually migraines and epilepsy are genetically related. So some kids would grow out of epilepsy and into migraines. It's almost very similar pathophysiological mechanisms, the two. So some parts of epilepsy are kind of like more severe versions of a migraine attack in a way. And a lot of epilepsy patients even have migraine.
That's interesting. How does that work? Why is the link there?
Basically, epilepsy is as migraine. It's an hyperexcitable brain. It's problems with your ion channels in the brain that make your brain super hyperexcitable, and this can be exacerbated by energy deficit. And when neurons fire in synchrony, and they all fire at the same time, you basically get an epileptic seizure. That's your seizure.
Right.
Uncontrollable firing, right? Mm-hmm. And a migraine CSD, a chronic cortical spreading depression, which is the correlate of the aura phase in migraine, which is this phase of visual, could be visual, but could be any other sensory deficiency that precedes the headache for about an hour and can be anything between 5 minutes and 60 minutes long. Basically, patients go black on one side of the visual field, or some go paralyzed. So it could also be like a aura of the body, right? Or you lose speech or something like this. But that's also basically in the back of your head. This is basically a cortical spreading depression, means that neurons fire in synchrony, go over the cortex in a wave, and that's followed by no activity. And that's basically when you then lose sight or lose control of part of your body or lose speech, wherever that wave is traveling to, basically. So synchronized, uncontrolled firing is basically simply put, the underlying physiological correlate of an epileptic attack. So migraines have that component too, at least to some degree. Also, anti-epileptic drugs are the drugs that are the most, or the, say, preventative drugs that are probably the most effective or among the most effective in migraine. So if you reduce your excitability in the brain, you can help a migraine attack. And there's also the link between hyperexcitability and energy metabolism, because basically what makes a neuron fire, the firing of a neuron, is called an action potential. And there's something called a resting membrane potential between a neuron and the outside of the neuron, which basically determines how likely the cell is to fire. Simply put, it's almost like a wall between, say, the ocean and the land. The wave are the action potentials. If you have a high wall, right, the wave is unlikely to go over the wall onto the land. So you're unlikely to get an action potential, which means your brain is calm. The lower the wall, and the wall would be this resting membrane potential, the lower the wall, the more likely the waves are to come over the wall. And whenever the waves come over the wall, the neuron will fire. Keeping this wall high, or keeping the membrane potential high, which in the neuron is done by basically carrying out ions against their concentration gradient to basically keep this a potential is an electric difference between inside and outside. In order to do that, you need to spend a lot of energy. So 50% of the brain's energy demand actually goes into carrying ions across their potential difference in the brain. 50% is massive. So if you have reduced energy in the brain, of course this wall is going to come down. When the wall comes down, your neurons are more likely to fire. What does that do? Well, first of all, you might get a migraine attack, but also most migraine patients have some kind of sensory sensitivity. So hypersensitive to light, to noise, to smells. Well, why? Because it needs much less of a trigger for the neurons to fire. If the wall comes down, they fire easily. So light becomes much brighter, noise becomes much louder, right? So I think that's how you can explain those other issues that come with a migraine attack before, during an attack as well. Could also be explained by this energy deficiency and by these neurons that are firing more likely. And the genetic predisposition here, the shared one between epilepsy and migraine would be, and there's so many different ion channels in the brain that basically carry ions across membranes. That's their function, right? And if you have some that are predisposing you for a lower wall already, or an increased tendency to fire, and you put yourself in an energy deficient environment by only eating carbs, right? Or your mitochondria are damaged, then basically those two come together and you get a migraine, or you get more migraines. And I didn't want to distract from the personal story, but maybe we come back to this later. I believe that migraines, one says that chronic pain has lost its warning function. That's what you say. Acute pain, everybody knows it's very important for evolution. And once it becomes chronic, people say it's lost the warning function, we just need to treat the pain. But I doubt that. I think that pain always has a warning function. A migraine is a very potent warning signal of our brain that it's in an energy deficit, that the oxidative stress is too high. It's a very, very powerful means for the body to force us to stop what we're doing, to rest, to go in a dark room. We're nauseated. We don't want to move. That's one of the most migraine symptoms. Movement makes it worse. Light makes it worse. So you shut off all sensory input. You conserve the energy you have until the homeostasis in the brain is restored. And then the migraine stops. And very interestingly, during a migraine attack, early studies about 50 years ago, and they've completely been forgotten about, showed that during a migraine attack, irrespective of what people are eating, ketone bodies are going up and lipolysis is going up. So it's like a counter-reactive response of the brain saying, oh, we have an energy deficit. Now we need to ramp up some kind of energy that we can actually use. I now know that my migraines are trying to protect me from something, and knowing that also helps you to kind of accept what you have in a way, I guess. It's not your body forcing this migraine onto wanting something bad. It's actually trying to protect you from something that is super harmful and might increase your risk for Alzheimer's in the long run, or for some kind of brain damage in the long run. Because there is migraine or stroke in patients that have migraine with aura typically for a very long time. I've been working in neuroimaging, as I mentioned before, for some time. You find there's micro lesions in the brain. People usually say a migraine doesn't leave a mark, but it actually does. So the more you get them, you actually do get to see it in the brain, even with like a very coarse neuro image of like 1 square millimeter, which on a much finer level, you'd probably see other things as well. Iron accumulates in the brain and all sort of things.
Yes, I have read that actually, and it makes complete sense.
Yeah.
If something is happening that your body is warning you against, it's likely to leave a mark of some kind.
Yes, and it hasn't lost its warning function. It's just that our environment has become so maladaptive to our migraine warning genes, let's say, that people have it chronically. And of course, that's debilitating, but that also means that they probably have some kind of oxidative stress level in the brain or constant energy deficit. And that's something you can also measure in a migraine with neuroimaging these days. They have about a 20% on average ATP lack in the brain compared to controls, even between attacks. 20% less energy. That's not benign. And that's episodic patients. That's not even chronic patients. So I don't want to know how much lack in energy in the brain a chronic patient would have. And all the body can do, it cannot talk to you. It can send you pain signals, right? It turns these ancient mechanisms on. It turns the pain cascade on to force you to stop whatever you're doing, to change something and tell you, hey, we're not doing okay. There's something wrong here, right? That's what pain tells you. And then in chronic patients, it's just that their genetic load is so high and their mitochondrial functioning might be this bad, and their other environmental situation with regards to food and energy might be this bad, that they're constantly reaching the migraine threshold, the warning migraine threshold, basically that the brain is always in such a state that it thinks it needs to warn them. back to the personal story, just to finish that off, basically I stumbled across ketosis. I was like, this is it. I started self-experimentation. It went very wrong at the beginning because I had no idea what I'm doing and what a ketogenic diet is. Triggered like the worst migraine ever. I think I was fasting and I wasn't in ketosis for like 10 days, which is crazy. My body completely had forgotten about how to make ketones or how to get them anywhere. But when I finally got it right, it was pretty amazing. Lots of self-experimentation followed, and then I knew that I wanted to do this in my PhD and nothing else. That turned out to be fairly tricky because everybody was like, you can come here, but you do what we want you to do. I mean, as a pre-PhD student, nobody believes you, and it was a fairly risky project. But then in Basel, and this is why I turned down Oxford in the end, is in Basel they said, if you come here, you can do it as a side project. And then before even starting, my supervisor here said he has to leave to Germany. He's leaving, he's gone. So my funding went. But that was basically the possibility then to say, okay, I'm going to make this my major project. I'm going to leave neuroimaging. It's interesting, but it's too far away from a solution. I want to do this keto and migraine full time. And in order to get a grant that funds a full phase 2 clinical trial, which is fairly expensive, we decided to go the exogenous ketone route, which is basically changing one variable only, adding ketone bodies, and find out what does the presence of ketone bodies change in a migraine patient with regards to potential mechanisms, and is this enough to show a significant clinical effect in those patients in terms of migraine day reduction and other outcome measures. And that's been going on for like 4 years now, I think, with the planning and everything, and we're in the last half a year. Last patient cohort is currently in the study, and then hopefully by next year we'll have the results of that.
How exciting.
But that's basically the journey. I'm towards the end of my degree, and I was able to deep dive into keto and migraine, which is amazing if you can make your disease your passion. It's kind of cool.
Exactly. So you not only diagnosed yourself, but you're going on to find the best treatment for yourself and for others at the same time.
Hopefully, yes, exactly.
And we'll talk a little bit about what your keto looks like later, because I know, having had a conversation with you before we started recording, it's going to play into something to do with what we're going to talk about. So I think it'd be better to put that a little bit later.
Great. Yeah, sure.
You have spoken about already a little bit about what migraines are, but perhaps you could just talk a little bit more about that, and also the connection you found with all the different triggers associated with migraines. Yeah,
so migraines are typically, that's kind of maybe one more funny anecdote with regards to what a migraine actually is. Because when I was 5 or 6 years, I had a favorite movie called Pünktchen and Anton. It's a German movie, and I used to watch it on rainy Sundays with my friends. And in there, the protagonist's mother has migraines. And her friend asks the dad, what are migraines? And he says, migraines are headaches that don't exist. As in, like, she's making this up. So for the next 10 years following, I actually believe that migraines is a term for a headache that doesn't exist, for a made-up headache. And then once I got them myself, I found out they're very real. So migraines are not headaches that don't exist. They're actually even more than a bad headache. Typically, they're from a headache from moderate to severe quality, pulsating typically, a unilateral, meaning they only appear on one side of the head, typically. It could be, some people have it strictly only on the right always. For some people, it swaps. But typically, you have a preferred side where it happens, at least at the beginning. Eye pain is very frequent. Then you have kind of a premonitory phase, which precedes the headache attack up to 1 day or even more. And there you typically have associated symptoms, neurological symptoms like nausea, light sensitivity, noise sensitivity, smell sensitivity sometimes. Moving makes it worse, and you have this like feeling of doom. Some people get really like agitated. Other people get super tired and super fatigued. And those symptoms can last throughout the headache phase. And then they will also typically last for the prodrome phase, which is basically the postdrome phase, the phase that follows the headache. That could also be days even, where you're typically very fatigued. And sometimes you have gastrointestinal symptoms. Most people have a lot of yawning. Maybe they pee more. So increased appetite. It's like your brain sensing there's something wrong, and now you need to eat as much as possible before the attack comes. A lot of people throw up. It's much worse than a headache because you can't ignore it. With a headache, it's typically your whole, more like a pressure type of a pain, and it's your whole head typically, and moving makes it better. in migraine, moving, any kind of movement makes it worse. And this pulsating, sometimes stabbing quality is also fairly common. Does that summarize? I mean, you could tell us what your migraine feels like. It's fairly individual. This would be like more a typical summary. Duration-wise, the diagnostic criteria says it's between 4 hours and 72 hours, so between 4 hours and 3 days, which is quite correct. Typically, if I have a migraine that's longer than 3 days, it swaps sides, so I know, okay, next attack is starting. It's not the same.
You've got another
anymore.
one.
Exactly. So that's how you can tell. And some people have an aura phase. We already touched upon this. About a third of migraineurs will have a phase of visual or whatever sensory defect. It will change, so it's only there for about an hour and then it will proceed. It could be paralysis. It could be, typically it's visual, so visual disturbances, zagged lines, blackout, whatever, these kind of things. But it could be any sensory quality, losing speech as well.
That's fascinating to me because I used to have these incidents when I was younger and they've always been a mystery, always. And I maybe had about half a dozen in total, but it was my late teens, early 20s. I thought it might be something to do with some type of epilepsy, you know, one of the really sort of low grade forms of it. I just wasn't sure. And the reason I didn't investigate it was because basically I didn't want to have my driving license taken away, which someone told me if they start investigating,
that's true,
thinking
actually.
you might have epilepsy, that's going to happen. But it never happened in any way like that. And I always had some kind of warning it was coming. But what happened was that I would kind of black out, but stay conscious.
Yeah.
So my vision would go completely.
That's a typical aura.
My hearing would become muffled. And the best thing I could do was just to sort of curl up in a fetal position.
Terrifying.
It happened once after a very stressful event where it was when I was at university in Liverpool. And it happened actually, I was on the phone to my mother and I think I terrified her because I said, I've got to go. I think I'm going to pass out. And I managed to get myself in the lift. I was on the 11th floor. And then it happened. I couldn't see. I could hear a little bit. And luckily, my roommate was either in the lift or was I think I managed to hit the right floor or was there when I got there. And I said, you're going to have to guide me to my room because I can't see.
It's insane. Yeah, it's so scary. It's so scary.
And it was very, very strange. And I had no idea what that was. And I've never associated it with migraines at all.
So the interesting bit is that all phases of the migraine attack can happen on their own. So you can have an aura without the headache following. You can have the headache without the aura. You can have premonitory phases without the headache as well. So people can have isolated auras, which is basically almost like a small epileptic attack. And depending on where this wave is traveling to, so you have to imagine, right? We said that keeping your resting state membrane potential upright takes 50% of the brain's energy. Imagine there's now a wave of electricity traveling over your cortex at the same time, and you then have to rebalance all the minerals in your brain. That takes a lot of energy. I think it increases energy demand by like 200% or whatever, and oxygen demand and everything. So it takes some time to basically get those neurons back into a state where they can fire again. If your neuron can't fire, you can't see, feel, or hear anything. So basically what probably has happened is that this wave was traveling across your visual cortex in the back, because all your vision is basically centered in the back of the head. So that means if something travels over there and basically enables all these neurons to do anything, that means that all vision is gone. That's very interesting. The studies on the, I think, Second World War, First World War, British soldiers had these very weird helmets that would basically stop at the back of their head. So you'd have a lot of, or quite a few soldiers coming back that had a wound or a shot into the back of their head, and they would lose selective parts of vision depending on where the bullet has hit. So if something would have hit all of your visual cortex in the back, then you just can't see because the neurons there are not working anymore. So brain function, at least in some regards, is localized in the brain.
Oh, how interesting.
What you probably had is an aura, a prolonged aura, maybe even so then you can't see. But for patients, typically when they have it the first time, it's terrifying. They think they have a stroke. But the good thing is about an aura phase, and that's where people shouldn't be too terrified or worrying too much, that typically function comes back within the hour. So it is more energy demanding. It does create more oxidative stress, which is probably why after an aura phase, a migraine headache starts, because of all the oxidative stress, all the metabolic strain it puts on in your head, right? I mean, it now has to rebalance all these things after this electrical wave of activity. And that takes a lot of energy. It takes a lot of electrolytes. It takes a lot of oxygen. It takes a lot of things to get it back on track, but it usually does. So your vision will come back, and your feeling in your arm will come back, and all these things. But it's a fairly terrifying event, and that would be a prime example for an aura, quite a bad one.
Ah, yes, how interesting. And it's what I realized, that it would pass fairly quickly. It was anything from, 10, 20 minutes. I just knew that, if I just lay down it's the safest thing to do, isn't it? Sit down, lie down somewhere.
And it's the best for your brain as well. Yeah. You rest, you're not spending energy on walking, for example. That would, again, expend energy that your brain would need to restore itself. So it's kind of intuitively, you do the right thing. How
interesting. You've solved a mystery.
Yeah. Yeah. I mean, there's other things I've been wondering about. And it's like little puzzles that you can solve along the way. It's kind of nice if you can explain your symptoms looking back, because and going to a medical doctor typically doesn't help, because they don't have explanations as to why things happen. They only have a symptom treatment response, typically. For an aura, there's some drugs you can take, but it reduces the aura frequency by like 20% or whatever. It's really not worth it, but it's good to know that when it happens, rest, lie down, don't do anything, maybe have some magnesium, some minerals, maybe, if you can get something down.
And it kind of makes sense that it happened at that period in my life, maybe, where, a lot of things are changing with your body, because it doesn't seem to have carried on. That was something that happened within a period of a few years.
Yeah. So your threshold would have been much lower, because if you're stressed, and that's something that's very interesting to me, because there's psychological stress and there's physical stress. And we always think that these are different things. But actually, they're fairly similar in the terms that all of these stressors or stresses, irrespective of whether it's physical or mental, is basically causing oxidative stress. And oxidative stress is the common denominator of all migraine triggers, irrespective of how unrelated they seem to feel. So fasting, skipping a meal, of course, causes hypoglycemia. Stressful oxidative stress increases. Stress, mental or physical, aerobic exercise, any kind of exercise. And that's why migraines typically have an intolerance to exercise, causes a lot of oxidative stress. And if oxidative stress exceeds your antioxidant capacity, so your body's ability to buffer this oxidative stress, then it will do a lot of harm. So if your exercise is triggering a migraine, it's actually doing harm, and you shouldn't be exercising, or you shouldn't be exercising at this intensity, because what oxidative stress also does is it's damaging your DNA, it's damaging your protein, it sets you up for all sorts of potential chronic diseases long term. So you really don't want that. Then sleep changes, oxidative stress again. You can see that in nurses, in people that change their circadian rhythm, those come with more migraines and metabolic diseases. Ovarian hormone changes, female hormone changes during the cycle will increase oxidative stress also. And that's where the pill comes in. I said there was a correlation between pill and contraceptive pill, which is basically given out like candy to any teenager. I found publications that show that pill onset increases oxidative stress, even in athletes, by 50%.
Wow, that's a
50% more oxidative stress. So now if you have a migraine genetics in your underlying system, then taking the pill might be enough to set you off with migraines for life, basically.
And talk a little bit about what you were saying about triggers being like a bucket, because it really explains, doesn't it, how some people get them a lot and some people get them rarely.
Yeah, so there's a few more alcohol, sensory triggers. People have weather changes as a trigger. Even that makes sense because of atmospheric pressure. It decreases or increases the oxygen that is in the air. Then we have alcohol, and sensory triggers would also increase oxidative stress, especially blue light, for example, is increasing oxidative stress not only in the eyes, but also through the skin. So we can see that all of these migraine triggers that we know are basically working on a similar pathway. Now, if something targets a similar pathway, that basically means that you are adding up the stressors. And you can think of a migraine threshold maybe as a bucket full of water. Some of us will have the bucket half full already when they're born because they have migraine prone genetics. Then you have, you're getting the pill, for example, right? So your migraine bucket is becoming increasingly more full. And then on this bucket, you're now adding your as a female, you're adding the cycles in hormones. For example, estrogen is very antioxidant. So during the time in your period when it's high, you're less likely to have this water bucket overflowing because it's kind of buffering. It's a bit like the estrogen is letting out a little bit of the water and increasing your migraine threshold. So this explains why some triggers like a glass of wine might be fine during some parts of the months, whereas if you have other stressors at the same time, say you haven't slept well, all of these things, you haven't eaten, you've done exercise, you've had some alcohol, depending on your genetics and your environment and how full your bucket already is, these individual triggers might then set off a migraine, have the bucket overflowing or not. Basically, a full bucket means migraine attack. And all these trigger factors together will maybe cause a migraine attack at some point and not at the other point. But if you're born with a bucket that is already full, you'll have a migraine all the time. Or if you're born with a bucket that is half full, but then you're on this worst diet or you have mitochondrial dysfunction because of toxins or other things, and that sets off that your bucket is full, then you also have a migraine all the time. So it's always an interplay between the genetic water load and your environmental water load. And when those two are added together, and environmental could be several different triggers, so many different things coming together. But if both of those come together and make the bucket full, then you have a migraine attack. From an evolutionary perspective, it makes sense that some of us have these hyperexcitable migraine genes, because typically you're already during attacks, you don't have this habituation phenomenon, which basically means habituation is a way for the brain to conserve energy, which means typically one of the rules is that your brain only encodes for change. So that means we're not like a computer. We're not firing all the time. Basically, a brain is only set up to fire when things change. So if a normal, healthy person looks at a checkerboard, say, or a white wall, and it's not changing, the brain will just stop firing. But a migraine brain will keep firing. It doesn't habituate. So it's spending more energy, but it's also basically alert all the time. And you'll see that a migraine patient typically is this perfectionist person and always kind of a little bit more sensitive to light, noise, and all those things, even between attacks slightly. But if you think about a tribe of people, every 7th person has migraines in the world. So there's like 1 billion of us. If you think about a tribe being made of, 20 people, you'd have 3 migraine genetic people in there. And they would be the first ones to hear when a lion is coming at night because they have light sleep. They pick up very small sensory cues. So those would be the ones that might be saving the tribe from a lion because they wake up first. So there must have been some kind of evolutionary advantage to having these migraine genetics around, because if a population is affected, 15% of the population are affected by a certain genetic combination, a genotype. There's no way that it didn't have an evolutionary advantage at some point in time. So that just means that our environment has changed so much that we're now at a disadvantage with those genes. But otherwise, it would not have stuck around that 15% of the population have this. So migraine really must have had some evolutionary advantage. And that was probably maybe on the one hand, and that's very speculative, but saving the tribe from things that require somebody to be alert all the time, even during sleep, more or less, like being hyper responsive. And on the other hand, it's a preserved mechanism that shows you something's wrong in your brain, where an energy deficit, oxidative stress is too high. We now need to rest. And it's very interesting how you can, and this is described in this Nature Neurology paper that I sent you that was in my thesis. Basically, we can now even mechanistically explain how we get from attack triggering to the resolution of the attack. Once via adaptive behavioral changes, so we're forced to rest and do everything so that homeostasis is basically conserved. And that is done via a molecule, one of them, a neuropeptide that is causing pain called CGRP. And CGRP is basically what now Novartis and Eli Lilly and other pharma companies are blocking with their CGRP monoclonal antibodies, which is these injection-based treatments that have just come out recently. And they call it the Migraine Vaccine, I think. It's an injection you get once per month. This is basically blocking the action of this molecule. But this molecule also seems to be part of mitigating the attack because it's very antioxidant.
Yeah.
So it's basically the body sending out a pain signal and a solution in the same time. So it's stopping you from doing things, but at the same time, it is kind of treating the initial problem. And another thing that is going on, like the third pillar of the whole migraine attack thing, is the metabolic changes that happen during the attack. One of the things that can fairly reliably, or was shown like 50 years ago again, to fairly reliably trigger a migraine attack in about 50% of cases is giving a glucose tolerance test. You give 50 to 100 grams of pure glucose to a migraine patient, and 50% of them will develop an attack in the coming hours, like 8 hours. It's always delayed, 4 to 8 hours. And if you look at those that develop an attack and those that don't, and their metabolic responses, fatty acids, lipolysis, and ketone bodies only go up in the ones that get a migraine attack. And they're eating normally. They're eating the same as the control group, basically. So if you want to trigger a migraine, you give them sugar, and then you see that there is a metabolic response. So basically, our body is trying to help us to save us there, really, because it's changing your metabolism. It's providing the brain with an alternative energy source because it is increasing glycolysis, it's increasing ketoneogenesis. It is sending out this molecule that is antioxidative, and other molecules too. CGRP is just one of them. But at the same time, this molecule also hurts because that's the only way we would be stopped from running around and doing more damage for the brain, expending more energy.
Let it work, yeah.
Yeah. So that's a long explanation. I'm really sorry. I think I'm rambling on too long.
No, it's fascinating. And I remember what you cited in that migraines used to be referred to as hypoglycemic headaches. So that makes perfect sense. It's that crash afterwards.
Yes, about 100 years ago. And then, modern studies came along, pharma came along, and then this was completely forgotten about for 50 years, almost a decade. And people have thought migraines might be a vascular problem, and then it was neurogenetic, and now it's hyperexcitable. And yeah, those things do play into the picture. But 100 years ago, this neurologist was treating his patients already with a low-carb diet very successfully.
And it makes perfect sense then. And that's the way I've always felt with this stacking system, with the bucket being full with the different triggers, that by changing your diet, you empty a load of water out of that bucket straight away.
Yeah, exactly.
And lower your threshold right down. Because there were all sorts of things that used to be reliable triggers for me, for migraines, things to do with the weather. So if it was really hot or if a storm was coming, smell was one of the biggest things for me. If I walked past someone who was wearing some perfume, cigarette smoke, I could guarantee that I was going to get a migraine straight away. They do still happen, but nowhere near as often. And so it makes total sense that by changing that big thing, changing my diet, has dropped that threshold down. I mean, it makes sense what you were saying earlier about the problem when you're having the migraine is that lowering in ATP function. And elsewhere you talk about with ketone bodies that they're capable of increasing, relatively speaking, to glucose, that you can produce more ATP. So it makes sense that by treating, if you like, migraines with ketones, you're getting that energy balance back in place.
Yeah, you have a more effective energy source there. That's true, per oxygen molecule consumed, basically. You also circumnavigate any problems or a lot of the problems with glucose metabolism and transport. So GLUT1 transporters might be deficient, which is basically the transport system that gets glucose into the brain. And insulin. Insulin is also needed for glucose metabolism. And ketone bodies are completely independent of these two issues. And then there's more that comes with this dietary change, right? You also have less hypoglycemia. You have a more constant energy supply because you can use your fat stores now, which you were not able to use before. You might have more micronutrients in your diet as well when you clean it up. You have less processed foods. Less processed foods means less oxidative stress again. So just getting ketones high is not the answer. We saw this very recently with a study, one of the first ones on cancer, brain cancer and ketone bodies. They were put on this very nasty Nestle shake product, which is like the worst ingredients that you could ever give to anybody, like rapeseed oil and processed oils in there. But participants were in very high ketosis, like 5 millimole, and they would still die as quickly as the control group. There was no change at all from being in ketosis, which is why I stress so much the quality of your ketogenic diet is key. It's not just about having ketone bodies present. You also need the antioxidants, the minerals, the vitamins. You need to make sure that you don't add trans fats or any crappy fats, which would make matters maybe even worse. So a high quality real food ketogenic diet adapted to your micronutrient need and to your antioxidant need. I think that's the key. Also checking whether dairy is a problem for a lot of migraineurs. dairy can be problematic, especially casein. So playing around with a non-dairy, more like paleo ketogenic diet can help. Yeah, but there's a lot of things that this diet can set right. And one of them is the mitochondrial functioning. Ketone bodies are antioxidative on their own. So they're antioxidants. And when you burn them, you produce less oxidative stress, which again puts less metabolic strain on already damaged mitochondria. And you have the transport issue. You increase mitochondrial biogenesis, so you have more powerhouses in the cell. Ketone bodies are able to reduce brain hyperexcitability via very many different, I think at least 4 mechanisms are now known. So that's also another issue that is key for epilepsy and migraine, is that you reduce or increase the inhibitory transmitters in the brain and reduce this hyperexcitability, which again will empty your bucket of water. Is one of the ways. And it's anti-inflammatory. Inflammation plays a role in almost any chronic disease. So again, there's water out of the bucket. And the nice thing about this ketogenic diet approach, or ketosis in general, maybe even in part exogenous ketones, we will have to find out, but is that it targets so many migraine relevant mechanisms, even the gut microbiome. So there's about 8 migraine mechanisms that we know are targeted or are potentially targeted by ketosis. And migraine is a very multigenic disease, as any chronic disease. So that means that many different pathways and things are probably involved in an individual migraine patient's migraine. You cannot treat a chronic disease with a one-target drug approach, because there's not one target in a chronic disease. And the beauty about ketosis and ketone bodies is that it targets all of these different mechanisms individually or together. A migraine that might be completely different in one person to the migraine mechanisms in another person, both of them might profit because some of their migraine causing mechanisms are affected by ketone bodies, and the other persons as well, because they just have such a big variety of metabolic and signaling action. Signaling being like they change gene expression or they change hyperexcitability. So they're signaling and metabolite at the same time. Alternative energy substrate, but also changing all these other pathways in a favorable fashion. And I think this is why they could be such a potent migraine and even other neurological disease strategy, because they target so many of the known chronic disease or neurological disease pathways that are involved, all with one molecule, basically. It's quite fascinating.
Yes, I was going to ask you about inflammation, because I've read that migraine is potentially an inflammatory disorder.
Also.
But it would make sense if you're causing this damage.
Yeah, but that's again too simple, right?
Yeah, exactly.
Some people say it's a hyperexcitability problem. The others say it's primarily inflammatory. The other people say, oh, it's vascular. The other people say, oh, but it's purely energetics. It's too simple. And also there's probably migraine subtypes that we just can't distinguish, because the phenotype, so what we see, is fairly similar. But there's 1,000 different migraines, right?
And are these also maybe secondary issues, like what you were saying when we were talking about the triptans, and you just touched on it there, that migraines were thought of as a vascular disorder.
Yeah.
But your argument is that that's just a secondary thing that happens because of it.
Well, the thing is, when you ask a migraine patient, they have this pulsating pain, right? So pulsating pain basically means that some kind of vascular receptor must be involved, right? So when I had migraines 10 years ago, they told me, well, it's basically that your arteries in your brain are dilating, they're pressing against the skull, and it hurts.
But that's a symptom rather than the cause.
Yeah, and the dilation, now they know that the dilation, it doesn't correlate at all. The dilation of the arteries and the pain onset is not, the timing doesn't fit at all. So it's definitely not a vascular disease. Definitely not. But the dilation could be the brain trying to get in more blood meaning more nutrients and more oxygen, right? So you have a delayed dilation in the brain. That could just be a secondary effect, as you say. It's probably not causative. But also the triptans are targeting receptors on arteries. But also that is just one thing that we know they do, and they probably do other things as well. They could also inhibit a neuropeptide that is involved in pain, for example, or work via a completely misunderstood mechanism. We don't fully understand why triptans are working at all, really.
So similarly to what you were saying earlier, actually part of this pain response that you're getting, but packaged up with that, is a potential treatment. So it's symptoms of the cause, but actually what's happening in your body is helping treat that original cause, treating that migraine. And actually by treating those symptoms, potentially you're dampening the treatment that's just happening naturally in your body.
Not with a migraine not with the triptans necessarily, or the analgesic. So I would definitely say, don't necessarily suffer through an attack and be like, okay, I'm never going to take triptans or ibuprofen or aspirin. I don't do that because it's just unnecessary pain and suffering. So I still take those because I know that those don't target the CGRP. But I think I would personally not do this injection-based treatment of CGRP monoclonal antibodies because I know CGRP, this neuropeptide, is also expressed very highly in the gut. And it's not a selective treatment. So you basically just block the action of one peptide in the body, which I think is kind of crazy. There's not a lot of side effects yet, but if you do that for a long time, I'm really not sure what it does because we're also inhibiting other bodily functions and we don't really know. So I'm going to wait and see. But I know that for some people, it really is a life changer in the sense that their pain is gone. For others, it doesn't work at all. I think it really depends on what kind of neuropeptide cocktail is responsible for your personal migraine pain. But you need to remember, you are blocking the pain. And the same goes for triptans. You can see there's a center in the brainstem that basically lights up when you get a migraine. You can see that is still ongoing while you're taking the triptans, which means the migraine is still there. Triptans do not abort the migraine. It's just not true. The same as analgesics. And this rebound migraine is not a rebound migraine when the triptans wear off. The attack is just there. And it's going to be there for that much longer if you take the triptans and then you go to work and you do your whole stressful day and maybe even do exercise and you're not resting at all. I would not do that either. So you need to be aware that the pain might be gone, but the migraine is still there. So you need to take care of yourself during this attack. If you don't want it to come back, you would still rest and do things a bit more slowly, in my opinion. So that would be my advice.
Yes, that's a good point. So you're taking something to get rid of the pain, but you should remember what you would have done.
Exactly.
Were you not to take it, which is
exactly that.
Lie down in a dark room.
Exactly. Don't endure the pain if you don't necessarily have to, and you can tolerate those drugs quite well. At least they're under 10 days a month. I would say you really shouldn't be taking them more often, day-wise, let's say. But yeah, don't forget that you have the migraine in the first place. That's a very good tip. Remember what it would be like or what you would be doing if you still had this attack. And it probably wouldn't be running, going to work, doing the laundry at the same time, picking up the kids and cooking and shopping and everything in like these hours of migraine. Probably not.
Yes, exactly. Still do what you would have done. And talking about different ways that you can help, maybe you could talk about some of the preventative treatments you've listed in your thesis. There were some different vitamin supplements, all sorts of different things, including the ketogenic diet.
Yeah, so it's quite interesting. There are some studies that show that antioxidants basically can help migraines quite a lot, as good as drugs actually. And it's those could be CoQ10, 300 milligrams. That could be riboflavin. Riboflavin is vitamin B2. 400 milligrams, so high dose, but also just a good complex B vitamin can help. Magnesium can help also. It's responsible for 300 enzyme function and we tend to be too low. So a good mineral supplement can help. And there's also alpha lipoic acid that has been shown to be migraine protective, which is a strong antioxidant. There's other antioxidants, astaxanthin. There has not been a study, but it goes into the similar line. So that's something one could think about as well if one wants to figure out the migraine. A best thing would be actually, these things are just done and added to the patients. CoQ10 you could always do, but there might be other minerals or essential vitamins that are lacking. So I would always try and advise to, if you have the funds, do a blood test. Minerals must be checked in full blood, and vitamins you can also check and see whether you might be lacking some of the things or even more. And then you can add a broad spend, high quality multivitamin or selectively take the things that you're lacking, could be zinc as well, and that will improve your mitochondrial functioning. And mitochondrial functioning is at the key for migraines. You can add a ketogenic diet if your mitochondria are not working because you're lacking some vitamins or you're completely toxic, for example. You can add ketones almost as much as you want. It won't help much because also ketones need to have mitochondria that are producing your ATP. It's like, okay, so in a car, right? It's a bit like if you're carb intolerant, if your glucose metabolism isn't well. It's like a petrol car and you're feeding it diesel all the time. It won't run well. right? But if you are now giving diesel to a diesel car, but the diesel car doesn't have an engine, it's still not going to run. So the engine is your mitochondria. You can swap the fuel, but if you don't have an engine in your car, you can swap the fuel as much as you want. The right fuel won't do anything. You need an engine that can make energy, that can power your car, right? So the first step is to get your engine right, and then you can change the fuel. So that's what I was also referring to in this paper that you were talking about, is get your mitochondria as best as you can. Antioxidants, whole food diets, and supplement. Either if you have the funds selectively, if you don't have the funds, with a good broad spectrum multivitamin in a way that has everything that we need.
And something like magnesium is a kind of thing that you can take without doing harm. It's very obvious when you've taken too much, isn't it? Because
exactly. And CoQ10 is the same.
It comes out rather forcefully.
Yeah. Ubiquinol is the preferred version. There's 2 versions of CoQ10, which might be worth mentioning. Mm-hmm. Ubiquinol is the reduced one. You'd ideally want that. With that, maybe 100 milligrams is enough. If you have ubiquinol, then you probably need to take 400 milligrams because it still has to be converted. With the minerals or the vitamins more, always try and take the active version. And for example, there's 4 different versions of B12, and cyanocobalamin is even toxic. So please also don't go to the supermarket and take the cheapest multivitamin you find. It's probably going to do much more harm than it does good, because if you have non-active vitamins, your liver needs to detox them again. Your liver is already busy with all other toxins and oxidative stress. So don't save on that. It's probably better to take nothing than take a bad supplement. And then there's other things that you can do. So we talked about vitamins and minerals. We talked about getting antioxidants in your diet, which is basically colorful vegetables if you can. And it could also be in supplement form.
This brings us quite neatly to a conversation we were having before, where I touched upon earlier asking you what your keto diet looks like. We were talking about, and a few things clicked in my mind again about what happened when I did my carnivore challenge. And one of the things that increased a lot were migraines. I had other issues too, with hot flushes and acid reflux, and my mood was bad as well. But when I mentioned that to you earlier, your eyes lit up and you said, yes, it was something that was very common, and that people doing a ketogenic diet, if they suffer from migraines, need to be aware of. And that's where the importance of these micronutrients might come in. Perhaps you could talk a little bit about that, because you just touched on it there with the fruits and vegetables of different colors.
Yeah, so basically I figured out for myself that a very restrictive ketogenic diet that only basically has green and white vegetables wasn't really cutting it. And carnivore would just be unthinkable. I think I did it for a week. It was horrible. There's something called an ORG index, and that basically measures the antioxidant content in foods. The foods, and even coffee, has antioxidants. The more colorful a food is, basically, the more antioxidants it has. That's quite blueberries are super high, chocolate, coffee, and then other colorful fruits and vegetables. And basically, if you think about a migraine patient, typically on a regular basis, exceeding their antioxidant capacity. So oxidative stress is a good thing in moderation, but whenever oxidative stress exceeds your body's capacity to fight it, it's bad. And if you take out all the foods and fats and proteins, they don't have a lot of antioxidants. This ORG index is very, very low. So basically, that means that likely, even though they have some ketone bodies present and they're somewhat antioxidative, they will still be lacking potentially, or they will still do better with increasing antioxidant via their diet to help their mitochondria fight oxidative stress. So I figured I'm doing much better having more fruit and vegetable, colorful, because I wasn't even eating carrots or tomato or peppers. That really can help. Getting more of those in. For me, it did, and for some patients also. So then you can either add exogenous ketones or MCT oils, or maybe it's even enough to just be in ketosis some of the times. So some intermittent fasting might help. A lot of patients also struggle with the fasting because there's something called glycogen resistance that has been found in migraine. It's basically the opposite of insulin resistant. Glycogen resistance means that you will not turn on ketogenesis and gluconeogenesis as much because you're resistant to glycogen, which is basically the hormone that tells your body when you're fasting to produce more energy. And if you're resistant to that, you get more resistant by fasting. So you basically need to do the opposite than an insulin-resistant person. You need to eat more to get this fixed. So that's another interesting aspect in a migraine that is different to other metabolic diseases, basically. But yes, so increasing antioxidants can be done with supplements, but also you can use the power of foods that come with micronutrients, that come with all these polyphenols and flavonoids and these things that can be beneficial for migraines, actually, and for mitochondrial functioning.
So you've worked your way to, you were saying before we started recording that your ketone levels are lower, but you feel a lot better. You've gone through a sort of stricter keto diet to now including...
And I can still be in ketosis. That said, though, it needed about, and that's something we find in epilepsy too, it needs about 2 to 5 years in an epilepsy kid on a strict ketogenic diet, and then whatever gene expression changes and therapeutic effects they had during the ketogenic diet is outlasting the duration of ketosis. So basically, if a kid has 80% reduction of seizures, there will be a point in time where they can stop a ketogenic diet completely, and these kids sadly go back to Western diet, and they will still have 80% reduction. And that might be something that's happened to me as well. So I was in higher ketosis for 2.5 years, and then was this point where I could go away and still have this reduction in migraine. From I had 20 days on average, and I'm now down to maybe 3 per month. I'm not sure if that was the major driver, but even during this more strict ketosis, I would feel better generally, also energy-wise, in terms of body ache and burning muscles. The more carbs not from grains, I'm not doing any of this, or even legumes. I can now eat beans again and stuff, but I wouldn't recommend that. But just from more colorful vegetables and having some fruits really helped me. And the only explanation for me is it's not the carbs, but it's the things that come with the carbs of fruit and vegetables that you cannot get with the meat.
Yeah, very interesting. And what do you feel about treating when you do have a migraine, treating it with exogenous ketones? And that just is a question actually about the trials that you're doing. Are they taking exogenous ketones sort of on a daily preventative basis, or are they taking them as a treatment for a migraine? It's
prevention. So you need to basically on a chronic basis empty the bucket with the ketone buddies. Mm-hmm. Migraine is a cascade of events, right? It could be, and I don't have much evidence, and for me it's hard. It's worked sometimes and sometimes not. If you catch a migraine super, super early and the pain cascade hasn't started, maybe you can abort it with exogenous ketones. But really what you need to do is increase the threshold or lower the water in the bucket on a regular basis. So we're using them as a preventative. Increasing the threshold, reducing the frequency.
So you're mimicking what other people are doing with a diet.
Exactly. So if you think about a migraine as a process, like a stone sitting on top of a mountain, rolling from a mountain. Once the stone gets rolling and it becomes full speed, it's almost impossible to stop that stone. And it's a bit like that in migraine. Once the pain cascade has started, once these neuropeptides that cause the pain in your brain have been released, you can take all the exogenous ketones you want. More energy is not going to stop the peptides from being around, right? It might make the attack less prolonged. It might make it less strong, but it's probably it's not a painkiller. It's not going to stop the pain, because pain basically is these peptides being around and the receptors being activated. So it would be very interesting to see, and that would be I would really love to do that trial with patients that are very experienced and can have this feeling of when the migraine is coming. If they take enough ketones early enough in the whole process, whether it could abort an attack even. But we don't have that data. I only have patients coming to me saying that it's worked for them. And that's really interesting. Also, on this ketogenic diet from the conference from Dominic D'Agostino, I had several patients that have seen a video before or read my poster, and they've done that and they say it works. But I don't know if this is a regular occurring thing. I cannot reliably make it work. Sometimes it would, sometimes it wouldn't. But now I'm doing so many things. I'm also on the road and I don't have them with me all the time. So I think I'm taking it too late when it doesn't work. Mm-hmm. When the pain is there already, it's too late. It won't do anything.
But it's kind of something that's maybe worth a try.
Oh,
and
certainly.
It's something that
have them around.
I've mentioned in my Facebook group. Yeah, and some people have tried.
Oh, really? That's great.
And they've really found it helps. So
fantastic.
For me, anything like that.
Are they taking the racemic or the D? Do you know?
Yes.
Racemic.
Just a racemic type 1 that you can buy on Amazon. That kind of type exogenous ketone. Yeah.
Interesting. Because they're lower blood glucose, the racemic ones. So it's interesting. So yeah, great.
Yes, I mean, it seems to me that if you can help with something like that, a supplement, rather than taking, any kind of pain meds. It's worth a try.
Oh, certainly.
It's something that I want to try myself.
Because, all these pain medication, again, it puts quite a strain on your liver, and your liver is already super busy in a migraine patient typically. So any medication has to be detoxed, and we typically underestimate how quickly you can kill yourself with ibuprofen because it leads to liver failure. So it's like, I don't know, you take 6 of them or 8 of them at one go, and you can kill yourself. So it's like, it won't kill you if you take 2, obviously, but that doesn't mean that taking 2 on a regular basis is not going to somehow negatively impact your liver with time, right? So if you can find a natural approach to that, by all means. And ketones, even if it's the DBHB, even better, because it's the endogenous version, the human identical one, because then you only have things around that are human identical. So that won't have any side effects because it's something that is around anyway.
Mm-hmm. They're harder to get hold of though, right?
They're harder to get hold of still. We're working on it. I'm working on it because I want it for myself. So maybe one day, hopefully. But yes, until then, racemic, and if you don't take it for like 10 years, there's also safety data for the racemic. It's not going to kill you. Certainly not. And if it helps, by all means.
Perhaps you could round up with what you call the 4-step approach to improving mitochondrial functioning and energy metabolism in migraines. Towards the end of your thesis, I read the recommendations that you have for everybody who suffers from migraines.
Oh yeah, certainly. So we've kind of touched upon the first 2, right? The first one we talked about is individualized supplementation of the micronutrients, and this could also be hormones. So not only vitamins and minerals, but also some people have menstrual migraines, which get really bad 2 days before their period, which is basically the time where your estrogen plummets and you don't have this oxidative stress protection. Your insulin sensitivity changes during that time. So sometimes people with menopause get really bad migraines, and maybe they would profit from some human identical. Again, that's the key. Don't take synthetic hormones. They're not the same ones that your body makes. It needs to be bioidentical. Hormones can help. So basically getting the base right, getting your engine working, getting your engines in the body working, getting the base, giving the body everything it needs, all the ingredients for good function first. And the second step would then be increasing antioxidant capacity. So that could be with food, with real food, with supplements, and also reducing oxidative stress. And that could be toxins. So smoking, too much alcohol. Actually, it's really interesting. If you tolerate alcohol well, it's basically the best test to see whether your liver is doing fine. If you have alcohol intolerance, that basically means your liver is struggling. So it's kind of nice to check in with yourself sometimes. Can you tolerate alcohol? If yes, your liver is probably doing okay-ish. Mm-hmm. If not, you might have to increase your antioxidants. The third pillar is stabilizing blood glucose. And this is essential for migraine patients that often get a migraine in the middle of the night because their blood sugar plummets. If you have easy carbs, like in this glucose tolerance test, typically what comes after is a delayed insulin response that is exaggerated, which then leads to reactive hypoglycemia, which you want to avoid. So basically low GI diet would be essential. So get rid of any...
And of course, that's where that one of the biggest triggers is skipping a meal.
Exactly.
You can just see how eating ketogenically is really going to help so much with that pillar.
And that point doesn't even have to be ketogenic. That could be low carb. Low carb can stabilize your blood glucose very well.
Anything you can do just to stabilize it, stop those real highs and lows.
The fourth pillar, the final pillar, is then if that doesn't help, then providing your brain with an alternative energy substrate might be key. And that's the ketogenic diet. Potentially, if you struggle and your liver isn't making enough ketones, or you have to put more vegetables in to feel better, this is where exogenous ketones could come into the picture, or MCT oil if you tolerate it. But if that has not helped yet, then you really need this alternative energy. Then you run better on ketones than you do on carbs due to transport issues or whatever it might be. So that's when you really should go stricter on a ketogenic diet, or get other sources of ketones in if you can. So that would be the 4-step approach that I summed up my thesis with.
Something that just dawned on me there, just going back to the beginning when you started talking about those different steps. If somebody has a regular, like with time of the month when they always get migraines, they can reliably know that they're going to get migraines, like you were saying, the couple of days before their period, say, and that happens every month despite all the other things that they've done. Would that be a good example when you were talking about taking exogenous ketones more as a preventative way, or right at the top of that pain cascade, getting in there before the pain starts, would it maybe be good for somebody like that to say, take exogenous ketones for those few days when they get migraines every month?
Certainly.
As a preventative measure.
You could do that, for example, before your period. Some people, period is stressful, estrogen plummets. If you have menstrual migraine, it might well be worth experimenting, adding exogenous ketones in 2 days before the period starts because they know they will get a migraine, and seeing if that helps things. That's exactly what you can do.
Worth a try.
Like a targeted approach where, or when you're extremely stressed and, you didn't sleep well and, you're about to get a migraine, maybe that's not wait for the first symptoms. Just take high dose exogenous ketones and see how you're doing.
Yes, because if you're saying that for it to be effective, you need to get in there before the pain starts.
Exactly.
It just suddenly dawned on me that might be a good way to do it.
I would definitely recommend that.
It's been wonderful talking to you, and I could go on all day.
Likewise.
But I know you have to go. Perhaps you could round us up with a top tip.
If there's a number one tip that I would recommend, and it's something that I had to learn quite painfully because I was one of those perfectionist migraineurs who's always listened to everybody else. And I took all these general advice on board, like sport is good for everyone, do sport, don't do that, whatever. The number one thing you can do and relearn is listen to your body. Your body will tell you what it needs. Once you get rid of your addictions or whatever, the best thing you can do is listen to your body. Does this feel good? Does exercise feel good? Does it trigger a migraine? Does cheese feel good to me? Does whatever. Does a very strict ketogenic diet feel good, or does something else feel good to me? Don't think because it works for somebody else, it's going to work for you. We're so individual. Nothing, even the color red is going to look different to every one of us. There's nothing that is basically sure to be the same with you than to somebody else. So the only person who knows, you have to become your own doctor. You have to take care of yourself and your health yourself and listen to your body. It's going to send the right cues if you listen to it. And the migraine is one of those cues. So the migraine is telling you something, and you need to change things in your environment until you figure out what is good for you. And this could even be getting rid of toxic relationships that chronically stress you, and put water in your bucket. So you really have to sort out through not only your diet, but also your supplements, your relationships, all of these things that stress you and that you might have not been aware of. All these things will make your bucket full. In order to get water out of the migraine bucket, if there's one advice, is listen to your body while doing it.
Perfect.
Thank you so much. Yeah.
It's been a great pleasure.
Thank you, Daisy. Have a good day.
And you.
Bye.
To get the resources and links from this show, please go to ketowomanpodcast.com/episodes. Please share this podcast with as many people as possible by sharing one of my links or just taking a screenshot of an episode that you enjoyed. Reviews really help raise the profile of the podcast, which gets it in front of more people, but also helps me attract a wide variety of guests. So please take a minute to leave a review on whichever podcast app or platform you like to listen on. It doesn't go unnoticed by me, the people who regularly like, share and comment on my posts. Your support really does mean the world to me. Thank you. Are you enjoying this podcast? Help me make more episodes and videos by making a pledge at my Patreon page, patreon.com/KetoWoman. Or simply hit the support button on the Keto Woman Podcast website. Don't forget to join in the fun on the Keto Woman Podcast Instagram and Facebook pages, and Daisy_Keto Woman on Twitter. Are you my next extraordinary woman? Maybe you've got an idea for a show, a topic you would like to hear about. Let me know how I can tickle your earbuds by dropping me a line at daisy@ketowomanpodcast.com. This week's quote is from Unknown. If you listen to your body when it whispers, you won't have to hear it scream. Bye-bye, Keto Lovelies.